All right, so this video is going to focus on how do we use the discriminant to find the number of solutions for a quadratic equation. Okay, so one quick thing to know real quick when it comes to finding number of solutions is take a look at the degree of the equation. So for example, if I had something like these equations here, what you're looking for is you're looking for the highest power of the equation. In this first example, it's a 5. Now, typically that tells you how many solutions you have. This first one here would have 5 solutions. This equation here would have 4 solutions because that's the highest power there. Whereas this bottom one over here, because of that 2, it would indicate that it would have 2 solutions. Now, that can generally tell you the number of solutions that you have in a given equation. Now, that is not always the case. You do have special cases. You do have solutions that repeat. You do have solutions that turn out to not work with the equation or end up being imaginary numbers or that kind of thing. So you can't always 100% rely on the degree of the equation. So for this particular video, we're going to be focusing on quadratic equations. If you do notice, the highest power is 2 for all of them. So at the most, you're going to have 2 solutions for these equations. You typically find those solutions by factoring, by inputting into the quadratic formula, maybe completing the square, doing those kinds of things. This particular question just wants to determine, hey, how many solutions is it going to have? We're not actually going to find the solutions. So the discriminant is this right over here. The discriminant is equal to b squared minus 4ac. That does come from the quadratic formula underneath the radical symbol. That's what's underneath the radical symbol in the quadratic formula. Now, if you look for in the discriminant, we have b, a, and c that we need to plug into. That b, a, and c is going to come from your quadratic equation. So basic quadratic equation here, ax squared plus bx plus c. Remember that a is always in front of your squared term, b is always in front of your x to the first term, and then c is always your constant. So the first thing you need to do when using the discriminant to find the number of solutions is take a look at the equation that they gave you and figure out what is a, b, and c. Once you do that, you're going to plug it into the discriminant, and based off of the answer that you get, it's going to let us know. I'll get to that in just a little bit here. Going through these real quick, I'm going to go through all 3 of them, and we're going to label A, B, and C. So A is in front of x squared. That is a 1. B is in front of x. That is a negative 6. Keep in mind the sign does go with it. And C is your constant over here, which is a minus 2. Let's do this for B and C as well. For B, A is 9, B is negative 7, C is a positive 7. And again with C, A is 1. Remember, it's always 1 if there's not a number there. B is negative 30, and C is 225. So that's what you want to do first. Make sure you know what your A, B, and C values are so that you can take those then and plug it into your discriminant, which is b squared minus 4ac. And we're going to simplify this. So b, we need to plug in for that first. B is equal to negative 6, so that's going to be negative 6 squared, minus 4 times a, which is 1, times c, which is negative 2. And we need to simplify this. So for simplifying this, order of operations tells us to take care of an exponent first. Negative 6 squared, or negative 6 times negative 6, is 36. Then we are going to multiply before we add or subtract. So I'm going to take this 4 times 1, which is 4. 4 times negative 2 is negative 8. We also had that minus sign there, so I'm dropping that down as well, since I didn't take that into consideration yet. But we're left with 36 minus a negative 8. That is a double negative rule, so 36 plus 8 is equal to 44. Now, this is how you're able to tell how many solutions you have. So this is the rule. If your answer is greater than 0, right? So it can't be 0, but anything bigger than 0, 1 on up to infinity. If your answer is greater than 0, you will have 2 solutions, plain and simple, 2 real solutions. So they're not imaginary, 2 actual numbers. Now, if your answer is equal to 0, you are going to have one solution. And if your answer is less than 0, what that means is you're going to have two imaginary solutions, okay? Because if they're negative, remember this is underneath a square root symbol is where you see this in the quadratic formula. And when you take the square root of a negative number, you start dealing with imaginary numbers. Doesn't mean you're not going to get an answer. It just means it's an imaginary answer. Okay, so greater than 0, two real solutions. Equal to 0, one solution. Less than 0, two imaginary. We have 44, which is greater than 0, so we will have two solutions for example A. Let's do the same thing for example B. For example B, we need to plug in b squared first, so b is -7, so that'll be -7 squared, minus 4 times a, which is 9, times c, which is 7. Remember to take care of your exponent first, so that's -7 times -7, which is 49. And then we're going to do some multiplying. 4 times 9 times 7, I am getting that is 252. And when we subtract this, 49 minus 252, I'm getting -203. That is a negative number, and negative numbers are less than 0. So that means, for example, B, we are going to have two imaginary solutions. So let's see what we get for example C here. So for example C, plug it into b squared. So b squared is -30. Or -30 squared, minus 4 times a, which is 1, times c, which is 225. Now 30 times 30 is 900. And then we have 4 times 1, which is 4, times 225, which is actually also 900. 900 minus 900 is 0, and because we get 0, that signifies here that we are going to have one solution for that one. So that's how it works using the discriminant to figure out how many solutions your equation is going to have.